So when you start working with variable speed chillers, you don't go very long before you start hearing terms like IGBT. And that is a really but that's a weird term. What does that even mean? It's a crazy acronym at that. Well, it's insulated gate bipolar transistor. We're going to talk about it some. I'm Holden Schamberger. I'm with HVAC Time. I also have Chiller Academy. And my main specialties in this industry, centrifugal chillers. And I also do a lot with VRF. We use a IGBT as a means of creating a pulse width sine wave. Now immediately I'm throwing more terms in there. Pulse width, what does that mean? End of the day, what we're doing with a VFD, so to have the IGBT, you're inside of a VFD or VSD, as some may term it, where we're taking input AC current from the grid. But we've got to make that current something we can use. So we're going to convert that AC current into a DC through a set of SCRs. That's going to feed a capacitor bank. Now most of the drives you're going to work on in the chiller world are going to be half wave rectifiers, which means that just half of the sine wave gets actually chopped off. We'll get into these things. This is just a little context as to what's happening when you're looking at this. So we go through the SCR, silicone controlled rectifiers. We feed into a DC bus, which is our capacitor bank, that feeds our IGBT. Now we're at usually about 650, 700 volts DC by the time the IGBT is receiving it. But in short, think of it as an inverter. It is taking DC voltage and then manipulating that voltage to simulate a sine wave going to our compressor. So because we can simulate sine waves through triggering negative and positive DC pulses, it's also known as PWM, pulse width modulation, we are able to make the motor think that it's getting a AC current. Now these compressors are designed and they're referred to as inverter duty. So these motors are capable of being ran on a drive. Not all motors are, so be careful of that, but if you've got a manufacturer design a compressor for this, you're going to be okay. So the IGBT has gates inside of it. The reason it's referred to as a bipolar gate is there's actually two gates. So the transistors function as gates or as switches, if you will. They're little switches, and this is all solid state, so there's nothing mechanical happening here. This is done through how we activate the silicon and the electrons inside of this little device. You can see one over my shoulder right here. This is an IGBT. So with that, we have gates. Those gates essentially act as coils. So we have to trigger those gates to activate the transistors internally. And the transistors are turned opposite to each other, hence the bipolar part. So what's happening is we can fire one transistor and we get a positive DC voltage output. Then we have to close that transistor and fire the other one to get a negative pulse output. And when you graph that on a sine wave, it literally is kind of this blocky stair step. Now technology's gotten better, so it looks a lot smoother than it used to, but it's all still the same basic theory. We're firing positive and negative DC pulses at really fast speeds, but depending on how fast we trigger those, will simulate how many hertz we're outputting. So we may be running at 30 hertz on the motor, or we may be running in some cases 200 hertz depending on the design. In short, end of the day, an IGBT is an inverter. We are converting DC to AC so that we can control the speed of our motor that we're running. Typically for us, it's going to be a compressor with a chiller. We can get way more into the details on this and drives designs. I'll do some videos on troubleshooting the IGBTs. And if you'd really like some more in-depth, structured, and interactive education like this, go to chilleracademy.com. I've built that just for somebody like yourself who's trying to learn what these things are and bring yourself up as a chiller technician. With that, I appreciate you. MTT, make the time for your family, for your spouse, for your kids. I'll see you around.